Yeah, camps on everyone. Let's start off. Good morning नहीं होता है, it's good evening. So that's good morning at night 8:30. Chalo, camps on everyone. Let's start off. Where are the rest? The last thing we did was this, the interaction between a ring and a dipole. Now, going ahead, dipole interactions. This was the end thing basically. So let's say we got two dipoles here, P1, and we got one dipole here, P2. So both are on the same axis. The distance between the dipoles is r, and r is much larger than the compared to the size of the dipoles. Find the force between them and find the potential energy of the system. So the two dipoles will in this case attract, and there's some energy between them. So how much energy is required to separate these two dipoles? So potential energy. System. The second case would be if your dipole P1 bar is this way and the other dipole is perpendicular. The distance is r again. So two cases. Let's do the first case. The dipoles are along the same axis. Find the force between them and the potential energy of the system. How does one dipole interact with another dipole? How do we approach this? Others, do keep your cams on. So first, let me show you one. Okay, I'll show you one brute force, and then I'll show something little more uh, easier or better. So first thing, if I really have no idea how to do this, I will go back to my Coulomb's law. P1, P2 bar. So what I'm saying, let this P2 be small q minus q, and let the distance between them be d. I don't know q, I don't know d, but I know P2 is q into d. Okay. Now from this dipole, when you're measuring the distance from here to this negative charge, the distance becomes r minus d by 2. From dipole to the positive charge, the distance becomes r plus d by 2. All clear with that? And what is the field due to the dipole on the axial line? 2 kp by r cube. Remember that? Due to a dipole, the field on the axial line E is 2 kp by r cube. That's your field. So the force would be, the field on the minus q charge will be minus q into field will be 2 kp by r minus d by 2 whole cube. plus small q, and the field at the plus q will be 2 kp by r plus d by 2 whole cube. This is p1. Take out the 2 kp1 common, take out the r cube also from there, and then you end up with 1 plus 1 minus d by 2r whole cube minus this is plus and this is minus, and this is 1 plus d by 2r whole cube. Since d is much smaller, I can do binomial approximation. 2 kp1 by r cube, and when this thing goes up, this will become 1 plus 3d by 2r, 1 minus 3d by 2r. Or you can just multiply, expand, you can neglect all the higher terms. Right? And when you do this, you end up with minus 1 goes off, and that would be minus 3d by 2r. You end up with minus 6k p1 q d by r power 4. But I know q into d is nothing but p2. So 6k p1 p2 by r power 4. That's your force between two dipoles. It's a dipole-dipole interactions are 1 by r power 4. This is one way to handle this. The same way I can find the potential energy also, charge into potential and everything. Clear with this? Right? Now there is a better way to do this. Yeah, dipole-dipole interactions are 1 by r power 4. Now the better way is this. A kind of something similar, but let's say we have a dipole here, P1 bar. This is the other dipole, P2. So now what we are going to do, same story. So this is plus q, this is minus q, but now I will say, due to this dipole, here the field will be E, and here the field will be E plus D. Meaning for a small distance of dr, the field will change by a dE amount. Now the force will be q into E plus dE minus q. So we get force is equal to q into dE. Multiply and divide by dr. So this will be q into dr, and this will be dE by dr. And q into dr is nothing but this is the distance between them. So I'll take this distance to be dr. That's a small distance. That becomes your P2, and this becomes dE by dr. E due to whom? E due to the first dipole. And what is E1? E is nothing but 2 kp by r cube. You want dE by dr. That turns out to be minus 6 kp 1 by r power 4. Substitute here. Minus 6k p1 p2 by r power 4. Faster? So we said let the field be E and D. So end of that, the same story. That this is much faster. Is that clear, everyone? The same thing now I can do for potential energy also. Now for the potential energy, what will I do? I will say here the potential is V, and here the potential is V plus dV. And the potential V will be, what is the formula again? Kp cos theta by r square, isn't it? So that's Kp by r square. Is there a 2 there? Two Kp cos theta. There is a 2 there. So we will say the potential energy of the system will be Q into V plus dV minus Q into V. Same story. We get Q into dV, multiply and divide by dr. So this is Q into dr, and this is dV by dr. Q into dr becomes your dipole P2, and dV by dr becomes minus 2 kp2 by r cube. What is this dv by dr? I don't think you'll get a 2 kp cos theta by r square. Wait, I think the potential, right? Potential is kp cos theta by r square. Yeah. So this would be minus 2 kp by r cube. Substitute there. And you're done. So the potential energy of the dipole is minus 2k p1 p2 by r cube. You have to provide this much energy to separate the dipoles. So this is the potential energy, and this is the force when the dipoles are on the same axis. Clear how to approach this? So this is a neat technique. It saves you time. You can do like this also. This also works. Here also you can do potential V and do binomial approximation and solve. You see which one you like, but this is the thing which I like. The advantage of this thing, you know what? You could have done this Rinka question also with this. You can say the field is E here and D here, and you could have tried it. But can you do the second part now? I showed you one. Now you get the second one. What if the dipoles are perpendicular to each other? It's a pretty good one. So if you see, advanced question was like this. There was a matrix matching. On one side, the options are the force between dipoles, force between a dipole and a charge, force between two charges. ऐसा कुछ options था. Energy between dipoles. On the right side, options are 1 by r power 1 by r square, 1 by r cube, 1 by r power 4. So you have to do matrix matching. So you need to know which one is belonging to which category there. Can you find the second part, everyone here? If the dipoles are perpendicular, can you find the force between them and the potential energy? How do we do this? Okay, let's see. You guys are still struggling with this. But this is a pretty good one. You should definitely try this on your own. So the second one, this is your P1 bar and this is your P2 bar. Now you have to be little, this thing like which one should I take? Like which one field should I actually Harry, please focus on the class now. Don't do nonsense. Where do you get time to do all these things, right? So here we are taking along the bisector. So why bisector? See, the problem is this. If I take P1 ka field on this, iska field will be like this, isn't it? And iska field will be like, it becomes really complex. The P1 ka field on P2 will be pretty weird. But if I take P2 ka field on this, that becomes more easy. So we can take this to be the bisector. Now, what is the field on the bisector? I hope you remember this. If you have a bisector, the field will be anti-parallel. It will be like this, E. And this is Kp by R cube. We have done this in the last class. If you see, these are the two general cases I told you. You have to definitely remember this. Mains, CET, bits, they do ask questions on this directly. They won't ask you on angles, right? So this was field D and this was field D plus D, right? So same story. We will assume this to be plus Q, this time to be minus Q. What is the force now? The force will be QE and the force will be minus Q into E plus DE. So basically this force will be, in this direction, like parallel to the vector. So then we get F is equal to minus Q into D. Same story, multiply dr and divide by dr. We get minus Q dr into dE by dr. Q dr will become your P1 and dE by dr, differentiate this guy, we'll end up with minus 3 Kp2 by r power 4. So force becomes 3 Kp1 P2 by r power 4. Clear with this? So the difference between this and that is a 6 here, and this is a 3 here. So there's a difference of 2. And same story. What about energy? The potential energy, now this is the best part. On the actual line, if you see, the potential is 0 because it's an equipotential surface. This entire line is potential 0. Potential energy is 0. There's nothing to do there. Meaning you can actually separate these dipoles without giving any energy. U is 0 since the potential along the bisector equatorial line is 0. It's an equipotential surface. Because if you guys remember the potential ka formula, it is Kp cos theta by r square, and here your theta is 90. All clear with this? That's your dipole-dipole interactions. Any doubts on this? So that is one way to handle this. Arya.
Sir, how do you know like the force is always perpendicular for
Because the
two
field is in this
dipoles?
direction, Arya. Force is always perpendicular. No, it's not perpendicular here, right? In case mein to force is along the axis. They're pushing this way along the line.
No, sir, for
In this
the
case,
perpendicular part.
how do I know? So force is field is this way, I got. Either it will go up or it will come down, right?
So like
The
I'm quite
charges.
confused because we have two dipoles. So
Where is the two dipoles? I am finding the force on one dipole due to the another dipole.
all right.
So that's how you find force between two dipoles, right? How will you find force between two dipoles? You take one guy, due to that one guy, find the field on the other guy and multiply that charge, isn't it? I hope that was clear, right? So this E is the field due to dipole 2. Right? You should definitely try this thing again. So that's one way to handle this. Okay, so this is one thing there. So dipole-dipole interactions, generally they'll keep it this way. I don't think they'll mess up more than this. Now, other than this, right, there's one more question. Did you guys get this? Did you guys try this? How to do this thing? See, so this question, right? First, let's do this way. Consider you take a full shell. So if you take the full shell, this guy, ka charge will be 2q to 1. The charge will become double and the radius becomes r1. And your half shell will look like this, which is your q2 and r2. Now, what is the field inside this shell? 0. So what is the force between them? 0. If you take a full shell, the force between them will be 0. Everyone agrees with this, right? Now I can split this into two parts. Now I can argue this can be written as the left half and the chota shell plus the chota shell and the right half. Does this make sense? If I combine the left half and the right half, you'll get a full shell, isn't it? Now, because the net force is 0, can I argue the force between these two? If this is F1, the force between these two must be also F1. Meaning, whether you keep the shell like this or whether you keep the shell like this, whether it's inside or outside, the force will be same on both of them. Is the symmetry making sense? If I take that half shell, chota shell, and keep it in a left hemisphere and right hemisphere, and if I combine the two hemispheres, I'll get a full hemisphere. Is this argument clear, everyone? That is one. The second thing, let's do the other way around. Let's take the chota shell full, that is your 2q2 and r2, and let's take the half shell now. Now this can be split into this piece here. I will take the chota shell ka right half and this big shell plus this shell here and this one here. Can I split it like this? Wait, I wrote it wrong. Like this. Is this clear? Did I do both same? I did both same. Previous one was right. Yeah. Hmm. Clear with this? But if you see the previous picture here, from here you can clearly argue this guy is looking like this. So this is still F1. This guy is looking like this, only the left and right became inverted. So this is also F1. Make sense? That means the force between this half shell and this full sphere is 2 times F1. So far, you're clear with me? Again, we're not doing any big stuff and all. We're just using symmetries there. Any doubts so far, please ask me on this. So now somehow, if I can find this force between them, which I can do, I'll show you how. Then I think my problem is over. Any doubts on this page before going ahead? All clear? Understood what we did? We made one thing full and we made the other thing full and then we just compared them. And then, so you just need to find the force between these two. Fair enough, I can do that. So I'll take the full guy. I'll take this one. Now, then what I will argue, so this guy is 2q2 and r2. So from the center here, somewhere, I will take a small piece, a small area dA. Then the force on this dA piece, dF, will be the field, the charge will be dq into the field. dq will be sigma into dA. Field will be k 2q2 kq by r square, but this distance is r1. So far clear with me? We are finding field due to the chota sphere on the surface of the hemisphere. What is sigma? q1 by 2 pi r square into dA. This is k 2 Q2 by R1 square. This is the force on that small piece. If you bring that area down, you'll get dF by dA. This becomes K Q1 Q2. 2 will cancel. We end up with pi R1 square R2 square. This is nothing but pressure on the surface. The force acting on that small piece by area is pressure. Why am I doing this? Because if I try to calculate the force, the problem is this. Do you think the force is same in every direction? No, then I have to take components and integrate, isn't it? Makes my life difficult. But if I can create this in terms of pressure, now won't my life become easy? So now on this shell, if I know the pressure is P, which is uniform, then I can simply say the force will be how much? Pressure into projected area, P into pi r square. I can use my projected area. This is nothing but the pressure, which is K Q1 Q2 by pi R1 square R2 square into pi R1 square. But you're saying this is nothing but 2 times F1. That's what we wanted to prove. So from here we get F1 is equal to K is 1 by 4 pi epsilon, and this 2 will come down. So we end up with Q1 Q2 by 8 pi epsilon R2 square. Q1 Q2 1 by 4 8 pi. Yeah, that looks right. That's your answer. Again, what I did, I can't do this directly. So what I did, first I said, let the outer sphere be full. In a full sphere, the field inside is 0. So no matter what you keep inside, the force will be 0. From there, I argued, if I can make this full outer sphere into 2 pieces, the left half and the right half, the forces due to the left half on this small sphere, the force due to the right half on that small hemisphere must be 0. So that means these two forces are equal and opposite. Then I said, let the small sphere inside be full and let the outside be half. Then we said, if I make that chota sphere inside, right half and left half, we can see clearly these pieces are looking exactly like these pieces. Only difference, ye dono pieces mein they got flipped. So from that we can argue these forces are also F1, but in this case both are in the same direction. That means the force on this guy must be 2F1. So if I can find 2F1, my job's done. And then I said, due to this 2Q2, I found the field on the surface, I found the force, I divided by area, I got a pressure. Then I went to fluid mechanics and said this pressure into area, projected area is the force. That should be 2F1 and you're done. Yeah.
Sir, can you please explain how you split the second diagram?
See, now, if I combine this and this, won't I get this? No, I took the full sphere, na? Dekho, aisa hai. Maybe you're getting confused with this picture, kya? Wait, I'll do one thing. I will draw this first. I'll draw this next. Happy? This is like this. This is like this. Better? This is looking like this. That is pushing here, so this will push here. This is looking like this. Now is it clear? I think because I drew that and that, maybe you got mixed up there. Clear with this? And the best thing about this question, right? You could have actually kept these things at an angle and the answer would have still remained same. If you had kept it like this also, independent of angle, the answer remains same. The force between them is independent of theta. Same argument you will do. You will take half and we can prove it. Is this clear, everyone? This is the kind of questions you will get. So yeah. Center of charge. See, center of charge you can use only when the functions are linear. Is the field linear here? No. Then why are you using it? पहले center of charge क्यों काम किया था? Think about it. Every time you used it, Either the field was linear or field was uniform. And then you could use it. All clear with this? Pretty good question. You should definitely try it again on your own without seeing this. Trust me, it helps a lot. That is how you learn. Don't think like, oh, itna tough question kaisa aayega? Right? Kaisa aayega? So if you don't do it again on your own, then second time, how will you get it? If something like this comes in the exam, you know what you will say? Oh, मैंने इसको कहीं पे देखा था, but I don't know what to do. What is the point of that? This is one. There is one more model I wanted to do. I'll just add it somewhere in the middle here. See. Let's do this question. I think I forgot to do this. Field inside a cavity. So let's say we got a solid sphere and we got a random cavity somewhere here. Rho is your volume charge density. This is a standard result which you should definitely remember. So this O is the center of the sphere and O dash is the center of the cavity. So you know O dash ka vector is known. Find the field inside the cavity. Find the field anywhere inside of the cavity. This is a solid sphere with a cavity. O dash is the center of the cavity. Now, when you see this question, right? First thing, if I see this question for the first time, I have no idea what the hell to do with this. That's a common feeling. Getting it? And that is how it will be for everyone. But now, that is what you have to, that is where your knowledge base will come into the picture. So if I see this question, this is what I will think. Okay, they're asking field inside the cavity and he's not even telling where. What is he even trying to ask? This is what they will think. Then, ho gaya na? Now all that irritation, frustration ho gaya. Examiner ko scold kar liya. Now get back to work. Now you will say like, okay, now abhi karna kya hai? Then the first thing that my thought comes is this. Okay, till now, where did I see cavity before? And how did I handle those cavity problems? When I think about this, now see, this is where your knowledge base comes into picture. And that's why I keep telling you, ratta marna, it's not a bad thing. You need to remember your standard models and your standard results. People think ratta marna bura hai. No, only remembering and without being able to apply is bad. If you don't have a knowledge base, if you don't have a standard models with you, you will become very slow. You have to derive everything. You won't have knowledge to recall. It's important you have a repository of models and knowledge. That is how your speed comes. People have this misconception like, oh, I will think. How will you think? You'll think in vacuum. When you don't have anything, what will you think about? It's like, I don't have any ingredients, I'll cook food. Seriously? What, you'll cook with air and sunlight? Photosynthesis karoge kya? Like, it's like that. So when someone says, right, sir, I don't like mugging up, I said, like, what? What are you talking about? You need to have stuff to think. So the first time I remember doing this was in center of mass. And what did I do there? Now I'll start thinking, center of mass mein kiya tha humne? And center of mass mein nahi tha. We saw this even in rotation also, movement of inertia. So whenever you saw a cavity, every time you did the same thing. You said, if I fill up the cavity, I'll take this guy. And if I fill up the cavity, I will get the full sphere. Isn't that the idea we did? That was the idea I did. And I don't know how to do this question, but I know how I handled my cavity still now. Is that making sense? Then I will think, okay, now let me try from that perspective and see what do I get. So the first time you encountered a cavity was this. And this is what we did. I said, fill up the cavity, get a full sphere, and then try to do this. The second time you encountered a cavity was in rotation. Then we did the same thing. We said, okay, take a full sphere, subtract the chota sphere, then you get this thing. So this gives me an idea. Maybe this is how I should approach this one also. And then I will say, okay, let's do that and see. That is how you think. Thinking matlab wahi hota hai. Thinking matlab, just sit there, you keep staring at the question and suddenly you become enlightened like Lord Buddha and answers will come to you. And that's not going to happen, right? So people unfortunately thinking matlab unko wahi lagta hai. You're sitting there and suddenly like God will come and say, okay, abhi, now it is time, I'll give you the answers, take it. So when you have a question and you keep thinking about it, and when you think about it and you don't get it and leave it, right, your brain is doing it subconsciously. And trust me, this happens a lot. Next day morning when you're brushing, right? Or when you're walking, suddenly it clicks and you feel like, oh, मैंने ऐसा क्यों नहीं सोचा था? So it happens, but you need to put a lot of work for that. So how do we do this thing? So I'll take a full sphere, then I'll remove this chota sphere, the cavity one, and then I'll end up with the shape that is being given. This is what I studied before in center of mass. I'm still using that idea only, right? So okay, I said great. So O and O dash, and let's say this point is P. This is O, so that point P will be somewhere here. This is O dash and the point P will be here. And now I'll say, okay, I know how to find the field inside a solid sphere, isn't it? I know how to find the field inside the solid sphere. And what is that? The field inside the solid sphere is K Q by R cube into that small r or whatever. But this thing, if you see rho is given everywhere, so I can do something better. 1 by 4 pi epsilon r cube, and cube is nothing but rho into 4 by 3 pi r cube into r. That would be rho by 3 epsilon into r. So that means I can write this field as E1 bar is rho by 3 epsilon OP bar. That is a field due to the solid sphere at point P. Now, luckily, both of them have same rho. The charge is different, radius is different, but the rho is same. So for this guy, the field will be E2, which is rho by 3 epsilon O dash P bar. So the field inside the cavity at any point P must be the field E1 bar minus E2 bar. And if you see rho by 3 epsilon is common, and you end up with OP bar minus O dash P bar. Then you can write O dash P bar as OP bar plus P O dash bar. And that's nothing but rho by 3 epsilon OO dash bar. That's the best part. The answer depends on the distance between the cavities. It does not depend where is the point inside the cavity. It does not depend on the size of the cavity. It depends only on the vector OO dash. It's a constant field. But have a look at this. In the next page, I'll put it in a much better way. Clear? This is a pretty good result. Right? Matlab, this is like a standard result you can expect in mains, bits, something somewhere it will pop up. Meaning even in a mains, they might not even ask the result. They'll simply say, how is the field inside the cavity? Is it constant, varies? They can pop up things like this. So if you have a sphere and if this was the cavity, the field looks like this. So if this is your O and this was your O dash, so if you draw a line like this, the field inside is like this. It's all parallel. The field is uniform. That's how the field lines will look like. I'll remove this blue things here. So field inside cavity is uniform. So you know how they can play with the question? They will say a minus q charge is projected from here, and this particle goes and lands on here. They can ask you find the time taken. This becomes a projectile motion, isn't it? If you have a uniform field, it's a uniform gravity, and this becomes a projectile motion question, and this becomes your range. You can literally create a whole kinematics question inside that cavity by projecting negative charge particles or positive charge particles. If you have a uniform field, you can play with this. So this will be rho by 3 epsilon O O dash bar. Let me give an example. So if it is like this, and if this is your O and this is your O dash, uh, and this distance was R, so this distance would be R by 2. So the field inside will be rho by 3 epsilon O dash will be rho by 3 epsilon O dash is R by 2 I cap. That is the field inside of the cavity. The field will be horizontal. I think it's an old PYQ, I guess, no? Yeah. All clear with this? That's one model left. So okay, it's an error also. It's a standard model, like yeah. There, with that, we are done with electrostatics. The dipole-dipole interaction was the last thing. This is one question I forgot. The next thing is gravitation. And like I keep saying, if your electro is good, gravity 80% should be quite straightforward. So we are going to use most of the results we derived in electro. So let's start off with this thing. So first thing, universal law of gravitation. The reason why I keep saying this is easy is because there's no concept of repulsion here. So what this thing says, every body in the universe attracts every other body with a force proportional to the product of the masses and inversely proportional. The same thing as Coulomb's law. Square of the distance between them. So if you have two masses, m1 and m2, they would attract each other. So this force would be F1 2 bar and this force will be F2 1 bar. Newton's third law, they will attract with equal and opposite forces. This force is given by F is equal to minus G m1 m2 by r square. This G is called gravitational constant. Whose value is 6.67 into 10 power minus 11. The negative sign indicates attraction. So you'll always get that negative sign here. And the best thing about this force, this is independent of the medium. Whether you keep the two charges in a water or anywhere, nothing happens. Remember, in case of charges, things do get affected. No idea how we got up with this. That is something. And they must have done a hell lot of observations. This force is independent of medium, meaning you keep them in water, vacuum, anywhere, it doesn't matter. And in gravitation, you don't have a concept of induction and conduction. You can't put a mass in front of the body and you induce mass. Just think about it, so weird it looks. Right? If you bring an elephant close to you, it induces mass onto you and you become heavier. Sorry. Induction of mass. There's no concept like that. And there is no conduction. If you connect a heavy person to a light person, the masses will flow till the one masses become equal. You don't have a concept like that. If something like that was there, the weight loss thing would have been awesome, isn't it? So there is no concept of induction and there's no conduction. Now, something to keep a note of here. Now you can compare this. If you look at the formula here, F is equal to K Q1 Q2 by R square. So what you can do here, you can replace that K with a minus G, right? Or 1 by 4 pi epsilon with minus G. So this is what you can do. Whenever you see epsilon, replace this with a formula 1 minus 1 by 4 pi G. And you get all your, what do you call it? Electrostatics formulas becomes gravitation formulas. Because Max does not understand the difference between K and minus J. They're simply two variables. So every electrostatics formula you derived, if you just dump this thing epsilon in place of that, and you will get minus 1 by 4 pi G. The formulas will convert for gravitation. Clear with this? You can put the magnitude. The minus indicates attraction, so that much though you know. Any doubts on this? Clear? Let's say a question. The first thing, binary star. Quite important for means. For some reason, they really love this. I still remember, I think in 2023 or 2022, in one paper, they gave two binary star questions. So what's a binary star? If you take two stars, let's say M1 and M2, if the mass of the stars are comparable, now if you see the sun and the earth, right? Earth is like too negligible. So it feels like the sun is almost stationary. But if you have two comparable masses, think of like this. Did you ever play this thing when you're a kid? Like you and your friend catch hands and both of you are just rotating round, round, round. Did you ever do this? I don't know what they call it. It's called Fugdi. I don't know what is that. So it's Fugdi, yeah? Okay. You played with this thing, ever did this thing? Now imagine you play this game with a first standard kid. What do you think will happen? The kid will literally fly in the air, isn't it? That's because you're so massive compared to that kid. If I play this with a first standard kid, the kid will literally fly, right? But if you play with this someone of equal mass, mostly, right, you both will rotate about the common center. So kind of like that. So in compared to sun, we are like that little kid. I play this sometimes with my niece and nephew, so they think they're having fun. I play all weird games with them. We play pendulum game. We play road roller game. They're the road. I'm the road roller. Then we play clean the room game. So I just put them on the floor and tell them to crawl. So, so we do all shit. It works. Two stars of mass M1, M2 with distance D. Now they have grown up. My nephew used to be a little very innocent. The kids are innocent at that age. You can tell them any bluff and they'll think it is true. So I told him this. I told him, see, school hota hai 7 days a week, right? 7 days a week, every day you have to go to the school, or else teacher will beat you. But for 5 days a week, if you go without complaining, I'll tell your mom, Saturday, Sunday, school mat becho. So, but remaining 5 days, don't cry, don't complain, chup chap chale jao. I will convince your mom somehow. I will ask her, please don't send in Saturday, Sunday. So 2 days tujhe isa break milega. He said, what do you think? He said like, ha, I will not cry. I hope he realized Saturday, Sunday is a holiday by now. So yeah, it works. We can tell them a lot of lies, like it works. The only problem when they realize not sure how they will treat you. Next time they'll look at you suspiciously, like "ये जो भी बोलेगा सच नहीं है. This guy is a cheat," something of that sort. Yeah, he's an innocent kid anyway. Even if you tell him something, he'll forget by next day. He won't remember. So that is it. You can always change and say, I didn't say this. And he's like, oh, what did you say then? You can tell him something and say, this is what I said. Oh, okay, fine. I just put him a chocolate in the hand and he will accept it. You can do this, I think, till they're something like 9, 10 years old. After that, the brains actually grow up. So yeah, it becomes difficult at that point. And once they reach your age, so you have become monsters. Like it is the other way around. Anyway, so about each other due to gravitational force. Find the time period for one revolution. So if these two things are rotating about each other, find the time period for one revolution. Now, these are called binary stars, okay? These things, even though they look like little rare, but in the universe, almost I think 8 to 10% stars are actually binary stars. They're really not that rare. The reason we can't see them is because the two stars are little close and they're so bright, it looks like a single point. I think, in Andhra, right? Telugu, Andhra mein marriage custom, there is one custom there. After the marriage gets over, they take the couple outside, and if it's a night time, right, they show them a star in the sky. You know that Saptarishi constellation, the seven stars? I don't know what they call it in English, but Saptarishi they call it in Hindi or Telugu. So in that, right, there's one star system called Arundhati Nakshatram. The star ka system is Arundhati Nakshatram. So it is actually a binary star. So Arundhati is the wife of a sage. So the two stars, one name is the sage ka name and one is his wife ka name. And these two stars are binary stars. They rotate about each other. So it is a symbolic way of saying, you both got married, just like these two binary stars. You also die like this and live forever, something of that sort, right? And so they show it as a symbolic thing, after the marriage there. And the best part about this, people have figured out binary stars in 1930s, and people have been showing this Arundhati star from centuries. Yeah, stars don't die out, so there's like your marriage is eternal types. And that was all fine. The story was good, but when my sister got married, right, it was afternoon 1 o'clock, and this guy takes them out and shows them in the sky. And I was searching, kya dikha raha hai? And they said, what are you showing? He said, yahan pe star hota hai. I said, seriously? Afternoon 1 o'clock. He said, hota hai. Don't keep poking holes into the theory and all. And I said, okay. When I got married, it was more useless. I went outside, he showed a star, and there was a big building there blocking the whole sky. I said, what do you want me to see? The building? So bad. Yeah, it works. So let's get this thing. So how does this look like? Let's see. I got something.
Our planet Earth, the third of 8 planets in our solar system, orbits once per year around our single sun. During the day, the sun is the only star we see in the sky. During the night, we can see countless other stars. But wouldn't it
So if you have multiple stars, you'll see multiple suns in the sky.
It's almost actually that uncommon.
So when you see from far, right, it looks like a single point, but when you get close,
It's almost impossible to observe a binary system of stars with the naked eye, because the stars are usually very close together and appear to be shining from just a single point. In
this is how they
fact,
go.
more than 80% of all stars are members of multiple star systems containing 2 or more stars. The way binary systems are formed isn't completely known. We simply can't live long enough to see such an event unfold. However, the most likely way for a binary star system to form is actually during the star's birth. Density pull the gap of star-forming region and offer the star set output
So that you can, I think this is more clear. Like, see?
On the other hand, closer binaries can have a huge effect on one another and even begin to transfer mass
This thing is actually rotating about a black hole. You can't see the black hole.
as they evolve and grow. System to us is a pretty rough.
So yeah, that's how the binary stars look like. So the two stars are just going about it. Let's get this. I'll post this. You can check it out later on. I think if you search online, you will find a star is being eaten by a black hole. So if the star gets too close to the black hole, the whole surface, right, starts getting pulled into the black hole there. Someone did get an answer. Ishman, you got something. Okay, let's get this. So what is the first thing there? Since there is no external force on the system, the center of mass will not move. That's how you start. So that means they must be rotating about their common center of mass. Since F external is 0, and here the center of mass is at rest. So therefore, the stars rotate about their common center of mass. So if you have M1, you have M2, and let's say this is your COM. So this guy is going, let's say, in this circle. And this guy is going in bigger circle. So they're going in such a way. After some time, M1 will come here. It's like a dumbbell, okay? And the dumbbell is fixed at some point and M2 will be here. They have to be always on the opposite side and this should be the thing there. So they'll have same omega. Now, if you write FBD of any one of them, I'll write FBD of M2. Let this distances be R1 and let this distance be R2. And R2 is nothing but M1 D by M1 plus M2. The distances are divided in the ratio of opposite masses. The center of mass divides them in the ratio of opposite masses. Perfect. So M2, what are the forces acting on this? The centrifugal force, which is M2, omega square R2. Remember, M omega square R is the radius of the circle. The gravitational force is G M1 M2 by distance between them, that is D square. When you do between sun and earth, you know what used to happen? The radius and the distance used to become same. Is that clear, everyone? But now the distance will be different and the radius will be different. And then you just equate them, you end up with Gm1 by d square is equal to omega square R2, which is m1 d by m1 plus m2. So from here you get omega there, which is g into m1 plus m2 by d cube. The time period is 2 pi by omega and you're done. There's a time period for one revolution. All clear with this? Yeah, the most of it did get it. Now, the variation of this, they can say there is a 3-star system, there is a 4-star system. In real life, they don't exist. Because when you have a 3-star or a 4-star system, right, they have to be on a regular polygon. Even a small disturbance, the whole system will collapse. But in a 2-star, even if the masses keep changing, it will still work out. There is kind of an equilibrium. But the other variations are this. So just tell me, how will you do this thing? If you have 4 particles on a square, side is A. Find the time period of this. I can give 3 stars, equilateral triangle, 4 stars square, 6 stars on a hexagon. You can do all that. Yeah, the main thing is the masses should be equal and the shape should be, yeah. The shape should be a regular polygon. Solve it, get the answer. Just write the main equations and yeah, finish it off. So let's take force is gm square by a square. So this would be F, this would be F, this would be F by 2. And this would be the centrifugal force, which is m omega square a by root 2. So when you equate the forces, you end up with F root 2 plus F by 2. The numbers are not great. Is m omega square a by root 2. Substitute there, you get omega, and the time period is 2 pi by omega. Easy? Clear with the steps? Any doubts on this? Let's see one more. Let's say we have a regular hexagon with 6 masses. M, 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 side A. On the axial line, you kept a particle here, small m. This distance is x. Plot force on this particle versus x coordinate. X is the distance. Let's call it a y. Plot F versus y graph. If y is much smaller than a, find time period for small oscillations. So if you leave this particle from small y, then what is the time period? So this particle is out of the plane at a height y. Is along the axis. And above the plane of the hexagon. So I wanted to plot a graph. Let's do for y positive, okay? Plot y is for y greater than 0. Only the upper part. So the stars affect the centrifugal force. Seriously, what is centrifugal force? God, it's a pseudo force. Pseudo force comes because you're in rotation, right? Other planets will affect the planet because of gravitation, isn't it? Why will they affect because of centrifugal force? Right? If something goes in a circle, the pseudo force is m omega square r. That has nothing to do with the other particles. Hope you guys remember that. So there, let's see how to do this thing. Take a break. Come back in 10 minutes, then we'll continue after this. Take a break. Come back by 9:40. After that, we can do this. Chalo, let's start off. Let's get this. How do you find the force as function of y? So let's take due to any one of them. So if I take due to this guy, so due to this one, the force of attraction would be in this direction. Let's this be F. This is theta. This was the angle, isn't it? So this was 90. Or maybe I can take the other one. Wait. So this one particle here will attract with a force F, and this would be in this direction. And let this be theta. And what will be that distance there? So distance between the particles, this is side A and this is y. So the distance r between them is root over a square plus y square. So the net force on the particle will be 6 times F cos theta. F will be G, capital M, small m by, I'm just taking the magnitude, negative indicates attraction, r square, which is a square plus y square, and cos theta is nothing but y by root over a square plus y square. So the force will be 6 G M M y by a square plus y square whole power 3 by 2. For small y, we can neglect in the denominator. The force approximately becomes 6 G mm y by a cube. This can be written as equal to ma. And that turns out to be acceleration capital A, I'll write it as A. So A is equal to minus 6G capital M by a cube into small y. That's your SHM. That's your omega square. So the time period will be 2 pi root over a cube by 6gm. Clear with this. That would be your SHM. And what about the graph? If you try to plot the graph, he's asking only for y positive anyway. So F versus y graph. This thing, doesn't it look like this kq x power 1 by r square plus x square whole power 3 by 2? It looks exactly like that function. Look at this. It's x by r square plus x square 3 by 2. Everything else is just a constant. It looks the same thing. It is y by a square plus y by 3 by 2. So at 0, it is 0. It goes up and then it decreases. And then it comes down. You can even find the peak value here. Maximum, minimum, you can do this. And this would be a by root 2. That's the peak value. So we can do df by dy is equal to 0 for f max. Is that clear, everyone? So initially the attraction force will increase, and once you cross a by root 2, it will again decrease. That is how the graph will look for this thing. So this thing looks like the force due to the field. Yeah, it's literally the field due to the ring. Clear with this? So 6 charges and all, it looks all weird and all stuff. How will the field lines look like this? Recently I was playing with this, and I didn't do for this, but I did it for electrostatics. If there are 6 charges on a triangle, I think last time did you remember I showed you that. I forgot to send you that link, right? No one asked me also that simulator, like you can put charges and get the field lines and all. So where is this? I think it didn't get loaded, I guess. It's not there. Where did I keep it? It must be there somewhere. Okay, I'll share with you later. Anyway, so that's about this thing. All clear with this? Great. Now let's see the remaining formulas. So the formulas, like I said, will look all the same. So if you have mass m at point P at a distance r, try to compare this with this formula. If you have point charge q at a point P, the distance r, what was the electric field? Electric field was kq by r square. What was the potential? Kq by r. So here, what is the gravitational field? Minus gm by r square. So wherever there is k, replace with minus k. And what is the potential? Minus gm by r. There, the formulas will look same. The reference is at infinity. So that is one. Second thing, if you have two masses m1 and m2 with a distance r between them, the potential energy is given by U is equal to minus g m1 m2 by r. If you have multiple masses m1, m2, m3, then the potential energy of the system is the sum of all possible pairs u12, u23, and u31. Now you can see the resemblance, I suppose, like they look exactly the same. You just need to replace all that case with minus g. Any doubts on this? Flux is simply a quantity, like anything that flows through an area is called flux. If water is flowing, we call water flux. People are going people flux. Field lines are going field flux. So yeah, you want, you can define it, but how useful it is a different story. All clear with this? Next thing, if you guys remember, field due to a finite rod. Anyone remembers the result? Can you write field due to a finite rod? I'll give you a 30 seconds. Like, how will you guess that?
Sir, how is the rod?
Finite rod. Finite rod, lambda is your linear mass density. This is point P. You know this thing. This is theta 1 and theta 2. Try to write the formula for this. Just give me a minute. Yeah, let's see. So how do we do for this thing? Remember the answer for this? So in the rod, what was the formula if you remember? 2k lambda by d sine theta 1 plus sine theta 2 away from the rod. Here it will be towards the rod. G lambda by d. So sine theta 1 plus sine theta 2 towards the rod. Remember the other component? K lambda by d cos theta 1 minus cos theta 2 towards theta 1. This will be away from theta 1 because of that minus sign. Now, how do you know which one is theta 1 and theta 2? You choose whatever you want. Like you can choose anyone as theta 1, anyone as theta 2. The signs will take care of themselves. Is this clear, everyone? So this is towards rod and that is away from theta 1. If you take an infinite rod, then the field will be 2g lambda by d. That's the field towards this. I hope you guys remember this thing. Clear? Great. Let's see a few questions on this. So we have a particle m, we have a particle mass 2m, right? And the distance between them is d. They're released from rest, both are free to move. So m and 2m move towards each other due to mutual gravitational force. Find their speeds when the distance becomes half. Others can on. This is standard means 1. Find speeds when distance becomes r. Let's get this. Remember your state 1, state 2. Potential energy, kinetic energy is constant. So that's how you play around. So this is how we do. Check it out. This is your state 1. What is the potential energy? Remember the formula minus G M 2M by D. Kinetic energy 0. When the distance becomes half, they will be traveling with speed v1 and speed v2. The distance has become d by 2. From conservation of linear momentum, we can get initial momentum is 0. Because if external is 0, you can conserve linear momentum. Initial momentum is 0. This is mv1 minus 2mv2. So they will actually have different speeds. Then what is the final potential energy? Minus g m 2m by d by 2. Kinetic energy half mv1 square plus half 2mv2 square. Initial energy is equal to final energy. Minus 2gm square by d minus 4gm square by d. This would be half mv1 square. So that is half m 2v2 ka square, and this is mv2 ka square. You can simplify this further. How much you get? So it will go that side. You'll get 2gm by d square, and this would be 3mv2 square. I think v2 will be 2gm 2gm by 3d square का root. Check. d आएगा, d square नहीं आएगा. 2gm by 3d. Clear with this? That's your v2, and v1 will be double of this. All clear with the steps? Any doubts on this? So if you see, the questions are quite similar. Like you can do the same thing there. So there it was a repulsion. Here it will be always an attraction. Clear with this? Then going ahead, let's see a few more similarities. Field on an axial line. So if you have a ring, mass m and radius r, and if you take a point P here, the field will be minus, if you guys remember the formula there, kqx by this thing. So it's minus gmx by r square plus x square whole power 3 by 2. What about the potential? Minus gm by root over r square plus x square. And how will the graph look like? If you plot the gravitational field versus x graph, be careful here because the sign is negative. The graph will actually get inverted like this. The field is on the left-hand side on the right, and on the left-hand side, the field is towards this side. The peak value will occur at r by root 2 and minus r by root 2. Everything else will remain same. The signs will keep changing. And if you remember, the extension of this was a disk. And I told you how to remember the disk value easily. If you have a disk, which is mass m and radius r, we can write sigma is your mass by surface area by r square. And if you take this distance to be z, this angle is theta. So cos theta is z by root over. That is fine. You know that thing anyway. Remember, you have to replace epsilon with 1 by 4 pi g. And if you guys remember the electrostatics formula, this was the formula, sigma by 2 epsilon 1 minus cos theta. So that 1 by epsilon becomes 1 by 4 pi g. You end up with 2 pi g sigma 1 minus cos theta. This is a gravitation field, everyone. Have a look at this. You can replicate everything from there. And then if you remember the extension of this, if r becomes infinity, this becomes an infinite sheet. And if you remember the formula there, E was sigma by 2 epsilon. So 1 by epsilon is 4 pi g. This becomes 2 pi g sigma. Any doubts on this? Clear? The next shape is your hollow shell. Again, hope you guys remember the formula. Mass m, radius r. The field is given by what is the field inside? Is 0. For r less than r, that's inside. For outside, it behaves like a point particle at the center, minus gm by r squared. You get a minus sign because it's always attractive. R greater than r is outside. The potential inside is constant minus gm by capital R. Outside, it behaves like a particle. And if you remember the graphs, like I said, the graphs will change a bit. You have to be careful with the signs. The graphs are negative. So basically the field will be 0, then it becomes negative, and then it drops. Here the potential is constant, and then it drops. So the graphs will be always on the negative side. And do you guys remember the self energy? What is the self energy of a shell? K q square by 2r. K ka place mein you'll get a g m square by 2r. You guys remember field pressure? Due to a shell, we get a pressure. If you remember the formula, it was sigma square by 2 epsilon. So here sigma will be m by 4 pi r square. And epsilon is replaced by 1 by epsilon is 4 pi g. So that becomes what? 2 pi g sigma square. This is what I was saying. Everything you learned there, you can replace it. There is no need to derive it again. All clear with this. So because of the gravitational force, the whole shell is under compression. Like so, this generates the pressure on the surface. Any doubts on this page? Now I'll give you a minute. Can you draw a solid sphere? Write it around a paper and see whether you got it right. Try. I'll give you a minute. Write the results for the field and the potential, the graphs, self energy, pressure, everything. Try to write it down. I'll give you 2 minutes. Let's see how much you remember for the electrostatics. Do it. Just write it in a rough. Then I'll show you. Then you can verify whether you got it right. These are the main formulas. Once you got this, then we can do all these problems. And this is what I was saying. The electro should be good. Everyone should try. Everyone try. Don't waste your time, please. Try focus on the class. Sudiksha, are you there? Sudiksha, are you there? Sudiksha, you're not there. Kicked you out. Okay. Next. Who else is not there in the class? Everyone should write your equations. Arya, keep your cam on. Let's write the formula, Sudiksha. Give it a try. Solid sphere, mass m, radius r. Let's see whether you got the formulas right. So the field will be inside minus gm small r by r cube. Outside is the easiest one, minus gm by r square. Remember, the potential is the most messed up one. I hope you remember that. Minus gm by 2 r cube into 3 r square minus r square. So here the graph will be linear but negative because it's attractive, and this is how it goes. Here, if you remember, it's not zero, it will be a parabola, and then it drops. V at the center is minus 3 gm by 2r. What is the self energy? 3kq square by 5r. So it's minus 3 gm square by 5r. What about the pressure? This is the gravitational pressure. If you remember the formula there, it is rho square by 6 epsilon r square minus x square. This was the formula we did in electrostatics. Rho is mass by volume, m by 4 by 3 pi r cube. And 1 by epsilon is 4 pi g. You can replace this. Rho square, that will be 2 by 3 g r square minus x square pi b I like. This is called gravitational pressure because the whole planet is attracting, everything is getting attracted toward the center. The whole planet is under compression. This generates a huge pressure. So if you keep digging a hole into the earth, at some point, right, the pressure becomes so high you'll get crushed. So that's another problem you will face. If you keep digging a hole into the earth, not only the temperature will rise because of the core temperature, and the pressure also keeps increasing. So the air there actually gets compressed because of this gravitational force. So the pressure does increase. There you can see the formulas. I hope you can see the resemblance. It works. These are the main formulas. If you remember, like everything formula, you can get it from there. All clear with this? Great. Let's see a question on this then. So we got a planet, mass m, radius r. You projected a particle mass m from the surface with speed u, which is equal to root over gm by r. Find h max. But this time we projected with 60 degrees. Find the maximum height from the surface. H max meaning maximum height from the surface. Remember, you can't use your kinematics equations because g is not constant. Find H max. So in the first case, it is projected radially. Second case, you projected with an angle. The first question is a pretty good means one. Second one actually goes into the advanced region. So let's see how will you handle them both. Yeah, right, Samay. You got the first part. Remember, this is simply work per energy. Instead of writing mgh, now we will write mass into gravitational potential. Try show you one. Listen, you're just interested in the maximum height, isn't it? So let this thing go to a certain height and stop here. So this is velocity 0. This is state 1. This is state 2. Listen carefully here. So what is the potential energy? Potential energy mass into potential at that point due to the Earth or due to the planet. So on the surface, what is the potential? M into minus gm by capital R. What is the kinetic energy? Half mu square, which is gm by 2r. At the extreme point, let this height be h. That's what we are trying to find. Same story. What is the potential energy? Mass into potential. What is the potential? Minus gm by the distance from the center, which is r plus h. Kinetic energy 0 because you came to rest. Initial energy is equal to final energy. So this would be minus gmm by r plus gmm by 2r is equal to minus gmm by r plus h. Gmm goes off, you end up with h is equal to r. Now, if you see, this thing is equal to the radius of the planet. These are not small heights, 6,400 kilometers for Earth. So you can't say g is constant. So we can't use your regular kinematics equations. Don't use u square by 2g. Is this clear how I did this, everyone? What about the second part? What happens if you throw at an angle 60 degrees? Now how will you find h max? Give it a try. At least give me the main equation. Let's see the steps. Everyone should try. How will you get this thing? So the second part, if you throw at an angle, how will you handle this? Do you think it will go in a straight line? No, right? Do you think it will go in a circle? No, right? If not going in a straight line, if it is not going in a circle, then what you do? I keep telling you this. Like there's only one way to do if you're not going in a straight line, if you're not going in a circle. Conservation of angular momentum, conservation of energy. Do you guys remember the statement? Now can you try? Give it a try. I'll give you a minute out. It's a good one. Okay, let's see. You'll actually get a quadratic. First, let's try to analyze the whole situation, how this thing goes. Later on, we will see these questions actually. This thing will actually come and crash on the planet. I'm going to ask you how much time it will crash on the planet. That would be the actual question later on, but this gives you a little context now. So when you throw it here, observe what happens here. This thing, right, actually goes in an ellipse. We don't know it right now, but it would go something of this sort. This would actually try to go in an ellipse. So this will actually try to form an elliptical orbit like this, where the center of the planet is the focus. We need not know that right now, but one thing I can say, when this thing is flowing, the force F is always passing through the center of the planet. So no matter where you are, the force is always through the center. Therefore, torque about the center of the planet is zero. So that means I can conserve angular momentum about the center of the planet. Therefore, torque is zero, and this implies L bar is constant. So this is my state one. And let's say when you're at the farthest point, your velocity will be perpendicular. I hope by now you realize this why. You cannot have a velocity along the distance. So this is your R max. This is your state two. So initial angular momentum, remember this is projected at 60 degrees. So initial angular momentum will be m v cos 60, mv perpendicular into r. This must be equal to, let's call it mu, mv small r. So this will be one relation, u r by 2 is equal to v into small r. Next thing, energy conservation, energy in initial one is equal to energy in state two. Initial energy, half mu square. Potential energy minus gmm by r. Finally, kinetic energy, half mv square. V ka value I don't know. Potential energy minus gmm by small r. I don't know small r. Half mu square is nothing but root gm by r. So the LHS becomes minus gmm by 2r. And v becomes here half small m. V is nothing but a u square r square by 2 small r square is minus gmm by r. You can substitute here. You can solve this. You'll actually get two roots here. Okay. Samyak got something. He's saying h is r root 3 by 2. So when you solve this, you'll get two roots. You'll get r1 and r2. So one of them is actually the minimum distance and the other one is your maximum distance. The reason you get minimum distance is because Max does not know that this guy is going to come and crash on the planet. So it is trying to give you a value on the other side, which is our minimum. If you remember, in school you must have studied, this is called apogee and perigee, something like that. Remember that? Aphelion, perihelion, there are words like this. You get a quadratic equation because you get two roots, you take the maximum one. Is this clear, everyone? So when you're throwing from planets and you're throwing with very good speed, you can't use your regular formulas. We have to use the conservation of energy. Clear with this, Param? Advait? Sit straight, everyone. Focus. Don't lean, slump. Be focused. You're in a class. Behave like you're in one. Right? Let's see one more. Again, we are using the same stuff. So next thing. Let's say we have a planet and we have a rod. This concept is called a space elevator. This is there in your NASA ka website. They have an idea like this. So the idea was this: we are going to take a very long rod, right? And we will rotate in such a way this rod will be always radial. So we got a rod here. So we have a planet of mass m r. We have a rod here of mass m and length is also r. So the idea here is this rod If you rotate with a certain omega, you can make sure the rod does not crash onto the planet. It just floats on the surface. The rod rotates just about the surface. Now you need to ask yourself why it is not falling down. Just above the surface of the planet. So if you see the picture, right, it would look something of this sort. It's not exactly the same one, but kind of like this. You can see how this thing is going on. So the idea here is this, the gravitational force is attracting it down. The centrifugal force is pulling it up. So if you can place this at a certain position and make it go in a circle, the centrifugal force will balance the weight and you can create a space elevator. And the idea is this. Then we can, take all these rocket ka parts or whatever, take them to the top surface here. You can assemble them at the top and then you can launch rockets from here. That way you can save a lot of fuel. So it actually becomes quite easy, to launch spaceships. You can put observation stations there. It becomes pretty cool. If you can actually make something like that, then first thing real estate people will sell you apartments also. Moon view, sun view, earth ka view. Ever seen those kind of apartment names? Hill view, river view. That be like real estate people will put boards. But anyway, so this is a thing there. So you have to rotate with a certain omega or else you're going to crash into the planet. So find that omega. So what is that omega, right, of the rod and the tension in the rod? If this rod is rotating, it will be under tension. This will be a good paragraph. As a function of x, where x is the distance from the center. Like, is the whole story clear, everyone? So when this rod is going in a circle, the centrifugal force is balancing the mg. So with what omega should I rotate this so that this rod does not fall onto the planet? And if it is rotating, then find the tension in the rod as function of x. Anyone didn't understand the question, please ask me. How do we do this? This is a good one. You should give it a try. So give it a good try. I'll give another minute or so. Then we'll find omega. The tension part will make this question really good. If I just ask omega, it is still in that range of that. But yeah. So all solve na Ishman, instead of asking and you have time to type, solve the question. Okay, let's see how to start this. So we got a planet here. So this is the rod. Now the problem here, see, every point on the rod is not experiencing the same force. The closer you are, you get more gravitational force. The farther you are, you get more centrifugal force. So there is a fight between these two. So at a distance x from here, if you take a small piece dx, so there are two forces which are acting on this, right? So there is a, if I try to write the FBD of this small piece, look at the forces. We have the centrifugal force, which is dm omega square x, the gravitational force, which is g m dm by x square. The tension is T plus dt. The tension is T because you're touching, there will be a difference in tension there. So let's see the first part, the omega part. We can make a statement like this: the net centrifugal force must be equal to the net gravitational force. So all the centrifugal forces acting on the rod must be balancing all the gravitational forces acting on the rod. That would be integral dm omega square x must be equal to integral gm dm by x square. Limits will go from r to 2r because the rod starts from r and it ends at 2r. And what is dm? Dm is nothing but mass of the rod m by r into dx. Substitute here. This would be omega square comes out m by r omega square integral x dx r2 dr, and this would be gm m by r integral dx by x square r to 2r. This would be 2r square minus r square. That will be 3r square by 2. And that guy would be 1 by x, so 1 by 2r. 2 goes off, 1 3 is left, r goes off, and m goes off. Omega square would be gm by 3r. R square क्या r cube आएगा, r cube आएगा. Yep, that should be the answer there. Please check the steps. So if you had figured out this part, that the centrifugal force is gravitational force, you have done. Any doubts on this?
Could you explain how we got the limits again?
The rod is starting from where to where, God? What is the length of the rod? R. What is the radius of the planet? R. So what is x? X is going from R to 2R, isn't it?
Okay.
Okay. Yeah. You can't take 0 to R. Rod is not starting from the center of the rod. Any doubts on this page? Clear, na, Trishi? Samyak? Ovia? Aditi? Clear? Vanishka? Vanshika, clear with this? Yashvi? The second part, how do you find the tension? There I already wrote that also. You want to find the tension? It is here. So from here we can clearly see dt would be gm dm by x square minus dm omega square x. What is dt? Dt is the small change in tension for a distance dx. And do you guys remember this? The open ends have zero tension. This is something we keep telling you. Like, if you look at the open ends here, the tension T is zero. If you take tension here, T is zero. So the open ends will always have zero tension. That means this rod has a zero tension on both the ends. In the middle, the tension increases. Because there's nothing to pull there, the open ends have to have zero tension. So now when you integrate this, you end up with 0 to capital T, which is dt. This would be gm integral m by r dx by x square. Limits will go from r to x. M omega square by r x dr, limits r to x. This would give you tension would be gmm by r. This would be 1 by r minus 1 by x. That's minus 1 by x, and this would be m omega square by r 2r x square minus r square. Check. This is your tension as function of x. It doesn't look great, but yeah. Clear with this? I can still do better. I can say plot tension versus x graph. Now, once you got the tension, we can still play a bit more with this. For maximum tension, we do maximum minima dt by dx is 0. But luckily, there is no need to do the differentiation. Why? Because I already know dt. So I can just directly put it equal to 0. So dt is 0. If I do this, you end up with gm dm by x squared. This is the next thing I ask you. Find the point on the rod with the maximum tension. We end up with gm by omega square is equal to x. But what is omega? X cube. Omega is just now we derived this omega square. Gm by 3r cube. We get x is equal to 3 to the power of 1 by 3r. That's another good one. That's the point with the maximum tension. So if you try to plot a graph between the tension in the rod versus x, the graph will start at r because that's where the rod starts. I don't know how the graph exactly looks, but it will go up. Then it will again become 0 because the tension is 0 at 2r. This is not a parabola. And the peak value will occur somewhere here at 3 power 1 by 3r. That's your maximum tension. Are the steps clear, everyone? And that is how the question becomes an advanced paragraph. So they can play with that. Omega, tension, a lot of things. So the problem with this thing, right? You can actually, theoretically, this can be constructed. The problem, the length of this thing, right, becomes almost like 35,000 kilometers. In order to put that in orbit, either you need to have very high omega or you need to have that very long rod. Because, you know, when it is rotating, shouldn't it also rotate with the same omega as the Earth? If it rotates with whatever omega it wants, you know what will happen? Sometimes it will be on India, sometimes it will be on Pacific Ocean. You have to fix it to the Earth, right? If you want to keep sending it. So you have to rotate with the omega. Then the length of this thing will exceed almost 36,000 kilometers. It's called a geostationary orbit. We'll see later on. And now the problem, if you take the length so much, the tension will be immense. So the tensions will range in the range of, 120, 100 gigapascals. That's the kind of tensions you'll generate in this. Now, the strongest material we use for constructions is mild steel, which can withstand up to 5 gigapascals. So we don't have any proper material, but we do have one material, carbon nanofibers. These things can withstand 120, 200 gigapascals easily. But the problem, the longest we have made so far is 15 centimeters. And the length of this whole rod is for 36,000 kilometers. So it's a problem with the materials, construction. You can't use humans to construct this because once you reach a height of 3-4 kilometers, we anyway faint. So we have to bring robots, nanotech, AI, all that stuff. And even if you start this construction, it might take around 200, 300 years. It's a long-term game, and yeah, who cares about this? But if you're building, it's a long-term thing, and interesting things you can do really interesting things. And when you build this, right, literally you have to build it on top of a river. This will be like a whole city there. So if you can build one here, if you can build one here, whoever builds this will be like a super part. Then you can connect all of them. Then Earth will have its own ring, like Saturn. And you feel like Earth is boring, then you can just take the ring and go away somewhere. So it works. Cool. Anyway, that's a bit about space elevator. So make sure to go through this and do revise all the remaining formulas. So electrostatics is done. So please start solving your material. Do wrap it up, right? That is a priority. Take time till next Tuesday. Do your electro first. Okay, with that, we'll wrap up for that day. So I'll see you guys again on Thursday. We'll continue from here. We will see more formulas of this and more variations of this. Okay, so any doubts, anything else, please stay back and ask, or else you are free to leave. So I'll see you guys again Thursday, same time. So take care, stay safe.